introduce myself, and Pavel can introduce himself. So yeah, hello, I'm Pasha. I'm the innovation lead at Epsilon. And by innovation lead, I mean someone who's doing all kind of interesting job that someone has to do, which is when this job is technical. So I'm sometimes involved in projects, but not always. And usually I'm playing around with different things. And one of the things I've been playing on around a lot is Shiny for Python. So we've decided to also lead this workshop. Pavel, maybe now you introduce yourself.
Hello, everyone. My name is Pavel. I'm a developer at Epsilon, and you can think of me as a teacher's assistant during this workshop where Pasha is teacher and I'm his assistant. I think I'm mostly here to support Pasha and you with questions regarding our Shiny, where it's relevant.
Cool. I'm creating a very quick pool, publish pool. So let's engage from the very beginning. Have you actually used PyShiny already? Please click. So we'll see the responses. Cool. Okay, so we see that like 1/7 of people around here have already used PyShiny, but majority of people haven't used. And now maybe let me ask also another question. Have you used rShiny before? Okay. I invite you to also share your expectations for this workshop in chat. Please free to do it. I'm very curious. What do you want to get from this workshop? I see that the people count are already stabilized. So I think we can start. Okay, I see that most of you already have familiar with rShiny and you're here for PyShiny. That's very good. And yeah, please write in the chat. Question is, what do you expect from this workshop? Okay, thanks, Kara. Okay. Thanks. Okay, I see that Alicia answered that she's already proficient with rShiny and would like to see how she can use PyShiny. So Shiny that she's well familiar with, but in Python. Good approach to development. Great, Harlan. I'm happy that you see this. That I see this question or like this point because we'll touch this definitely. Why not to use reticulate to interact with Python? Yeah, Thomas, that's a good point. Maybe we'll also answer this thing. Good practice and recommendations regarding deployment of PyShiny apps. Yeah, I think, and here, yeah, we will also maybe briefly touch it. See if how packages and third-party code work in PyShiny. Okay, Okay. So thank you very much for all the answers here. And maybe let's start. So let me paste links once again. First, the whole code of everything that we are talking about today is in this repository. As you can see in this repository, it's a slightly adjusted version of workshop that has been run by POSIT during the POSITConf in August last year. So if you attended that workshop, in this one, you'll have some different perspective, mine perspective. This is those materials are Quarto website, and this is the deployed version of the website on GitHub pages. And all the exercises will be on this webpage. So we'll use Shinylive, and we'll also talk about it. What's actually Shinylive? As the point is that you can run all the exercises in the browser, which is quite cool because you don't need to install the environment, and it really, speeds up the workshopping, I think. I think I wanted to share something else. Yeah, and if you've already been to this workshop, you've done those exercises, try to catch things that haven't been covered. Probably the development experience and the development setup of coding in Python wasn't covered that much in the previous workshop. Yeah, let's start. So let me share this tab instead. Getting started. Hop. Welcome to Shiny Python workshop. Regarding the name, so it's almost like dependency management in Python. It's a bit of a mess. Some people call it Shiny for Python. Some people call it Shiny Python. Some people call it PyShiny, and we use those names interchangeably. It hasn't been set there's no one proper name, defined by POSIT, so we can use it interchangeably. And don't be surprised to hear about Shiny Python here, and Python for Shiny here, and Shiny for Shiny somewhere else. The only exception is Shinylive, and Shinylive is actually a concrete thing that is different, and we'll cover it in a second. First, a huge shout out to Gordon and Joe from POSIT, who prepared those materials originally. So we had much less work with Pavel. And yeah, thank you very much. I want this to be noticed. So assumptions. Assumption before the workshop is that you have some basic experience with Python, and that you have some basic experience with RShiny. It's not needed, but it helps. And why it helps? Yeah, maybe let's go to the goals of the workshop. First, we would like to go through mechanics of Shiny apps in general and how they work. Why? Because PyShiny application works very similarly to our Shiny application. Maybe not in terms of actually the style of coding is very similar. You also write like a server function, and in this server function you write some different functions and so on. It's also similar in terms of the UI because you construct UI in a similar way. Namespacing works differently in Python. Fortunately, we don't have this, the honey modules, box, and other kind of a mess. In Python, we have proper imports, so it simplifies how you can do namespacing. You'll see it in action in a second. But yeah, first let's refresh Shiny mechanics of Shiny apps, then how to build a PyShiny app, and we'll talk about static content, so without any interactivity. We will touch an interesting point, Shiny Core and Shiny Express. So Shiny Core is like our Shiny. So you define the UI, the server, then you have app that takes server and UI and so on. And Shiny Express is much more like Streamlit. And if you happen to use Streamlit and you've wondered, oh, why I have to write so much code in in Shiny, in Streamlit, it runs all nice and like it's very simple. I think I have a very good example that has like 15 lines, and in those 15 lines, Shiny outshines Streamlit very much because of the model, how the reactivity works in Shiny and in Streamlit. Yeah. We'll go through how to include reactivity in PyShiny apps, and we'll also touch custom UI part. And I will show you a bit of Shiny modules. And we also will talk a lot, I think, about what Python has that R doesn't have. Because one thing is just having PyShiny and RShiny, but the other thing is writing in Python and writing in R. And the language itself has some features that may help you or not help you when developing things and working in project. Yeah. Workshop workflow. So we'll go through presentation and exercises. Yeah, all presentations, all exercises and slides are running live on the website that I've shared already. Maybe I can highlight it right now. Yeah, we'll go through it later on. We can go through testing your setup and so on later on, but I don't think that that's important for now. Maybe let's go to Shiny. What's Shiny? You know what's Shiny. Shiny is like a framework for building dashboards by POSIT, and you can have this interactivity and so on and so forth. Cool. But maybe some of you have noticed that, well, this is Quarto website running on GitHub pages. So there's no server, right? Like this is just a static, this is just a static website, and we have Shiny app here. And you may wonder, okay, but how it's achieved? So it's all achieved by Shinylive. And Shinylive allows you to use a thing called WebR. And this WebR, WebAssembly, WebR is for R, and pyright is for Python. So you can have Shiny dashboard in the browser without any server, and all the interactivity happens on your machine. For some of you, I imagine it's not that convincing or interesting, but I think that for some it might spark something in your mind, like, oh, so it means I can now run and create dashboards that don't need any server to run. And yes, you can do it with Shinylive. Is there a limit to the size of the app you can run with Shinylive since it runs on the user's browser? Yes and no. I mean, I would say that there's no size limit in general. You can think how different apps are running in your browser. So for example, you can have VS Code running in your browser. You can have Slack running in your browser. So these are pretty large applications. If you want to upload like gigabytes of data, then probably Shinylive is not the perfect way to dashboarding. But if you want to work with some smaller data sets, why not? It shouldn't be an issue. And yeah, because it's serverless, it means that the whole Python actually works in my browser, and this Shinylive works in my browser. And it also means that I have to download all the Python and everything, all the Shiny things, to my computer. In 2024, it's usually not an issue. The bandwidth is, fairly cheap and so on. Maybe it's not so, this technology has some pros and cons. Does it answer your question, Emmanuel? Yes, thanks. So this is what's Shiny app, and we actually also covered what's Shinylive. And just so you know, because of how pyright, so WebAssembly for Python is, let's say WebAssembly for Python, it's not that simple, but anyway, because of what's possible in Python itself, Posit was able to create Shinylive already like 1 year ago. And they're working on Shinylive for R. It has been released from beta, I think, some time ago, but still it's in much earlier stage, and it's harder to run your R packages in R Shinylive, but it's being possible, so to say. So you can expect that in some in few months, maybe years, you'll be able to run also your R Shiny dashboards in a browser without any server. Cool. Key features of Shiny. And those are by Gordon and Joe, so we can maybe argue with them, but easy to develop. Yeah, like there's not that much boilerplate, and definitely dashboards are extensible, and it's easy to add, a new input and maybe add some new plot. You don't have to change the whole layout of the page to add one button, for example. Efficient, and by efficient, they probably mean that this is reactive framework in which when I change the slider, only things that depend on this slider are being re-rendered. So if you go back to this dashboard, okay, maybe it would be better if we had two plots and we had one slider or one toggle for that would affect only one plot, then the other plot would not be re-rendered, and only one of them would be. We have a question from Octavio. You can run, or any coding you can run. Maybe let's leave this question for the time when you'll be doing exercises, and Octavio, please ask then, because I would like to answer, but maybe not now. We have key features. Why Shiny for Python? Yeah, so Shiny is designed to take you from prototype to production, and we are actually doing this at Epsilon a lot. We're doing a lot of Shiny dashboards that are, production dashboards for Fortune 500 companies and so on. So you can definitely do production ready apps in Shiny, and also you can very easily create a prototype in Shiny. Especially with Shiny Express, that we'll see later. I think that's another person that has these issues, but maybe someone from the Ring Central will take care of those issues. Anyway, let me come back to Shiny Express. Yeah, Shiny Express is the way to write Shiny apps, almost like Streamlit or like Streamlit-ish, in Streamlit-ish way. Yeah, efficient enough to handle complexity, blah, 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 protection ready, cool. What might be interesting for you is that we've prepared comparisons of Dash, Streamlit, Reflex to Shiny, so you can see how those different frameworks compare to each other. And I can also talk a bit about Jupyter notebooks, which are a different species. Yeah, so you have three things in Shiny app. You have inputs, outputs, you have some rendering function, and you refer to those inputs in those rendering functions. This is an example PyShiny app. So probably it's very familiar for you if you're in this 90 or like 85% that, in 80% that used already are Shiny. But for those 19% that haven't used it, this app will have a slider, will have like the slider identifier, a name of this slider. It will be the minimal value is 0, maximum is 100, default value is 20, and we'll have some text output. And then this is the UI, and then we have separated server, and the server, we say that we'll render some text, and this text has this ID, this have to match, okay, and we will return n times 2 is, okay, so we're calling input, and then this ID times 2. And we create the app, and we run app like Shiny run app.py. Fairly simple, I guess. So those were inputs and outputs. So places, we'll take value from here, we'll do something with it, and we'll put the output to this, let's say, container. We have rendering function. So yeah, this function, txt function, will render output that will be put here, and because it's an output text, we have to write render text here. I hope it's very straightforward, and we have to refer to input. So to get this text, we take the input. And important thing is that we're taking the input and we're also calling it with parentheses. Yeah. UI functions are in the UI submodule. And this is a bit different than in R because of how namespacing works. You can see here that all the UI things are in the UI.namespace. And because Python is a statically typed language since a few years, I type UI.something and I already have the nice help from VS Code or the other or some other idea I'm using, and it suggests me that, oh, maybe I want to use input something. We will see an example of this in action. Yeah, in UI submodule, inputs start usually with input underscore star. We have output star, and we also have functions like h1 or p, and this would create a header like in HTML header, or the p
Paragraph.
Paragraph, yeah, paragraph. And we'll see how to lay out those things in later session. Server function. Every Shiny app needs a server function. It can be an empty function. We'll see this as well later on. But server function executes for each user session. So it means that it executes separately for different users. It might be important if you create application that runs for different users. And basically in this server, you do calculations based on the inputs from the user and also render what should be, rendered to the user. I hope it's not boring, but I want to get through everything from the very beginning. So even people that haven't used PyShiny nor RShiny have, something that they can get something from this workshop. What's important actually for everyone that wants to write things in PyShiny is that those should be the identifiers, names of functions under render decorator. This thing is a decorator in Python. It's nothing, mystical. Those ID have to match the outputs defined in the UI. And we just use output render dot period thing that we are rendering. So we can have render text, render plot, render data frame, render image. Yeah. You can also specify some other additional things in this decorator. Just so you know, we will not spend time on this. So do we have? Okay. Now let's go through common problems because I want to get as quickly as possible to you doing exercises. Common problems that the output doesn't render, the output doesn't update when input changes, or you have some other weird error. And one important thing is to use inputs with parentheses, not without them. Then another thing is remember to check whether the ID has a match between the output and the render function. Blah 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 blah. Nothing important. However, to summarize this getting started introduction, most Shiny app development consists of three things: adding UI, adding rendering function, and connecting everything together. However, I would say that at some point you have to refactor code into modules and functions, and we'll touch it briefly in one of the further sessions. Now, please go to this website. Let me paste the link once again. It's still the same link, nothing has changed. And we can go to exercises. We go to exercises and we go to Hello World. And here you have the goal. You have problem. And you can write some code here. And you can press the rerun app button or like Command Shift Enter, and you will get something here. And I encourage everyone to now run it and try to go through this exercise, and also go through this exercise. And I think that this example, or like this whole website, also nicely shows that you can run those Shiny applications, Shiny dashboards in Quarto document in static website. And I'll get some water.
So Samuel, you can go to the link that is posted, which says Shiny for Python introduction, etc. And on the navigation bar on the left, if you click on Getting Started, the first element, it has exercises sub-element, and you can click on Hello World, and it will redirect you to the page that Pasha is currently on.
Exactly. Do you have any questions so far? Either I'm doing a very boring job or a very successful job, because no one of 144 people here ask any questions. But yeah, it worked. How do we know solution for is not data.frame? I really like the question from Kai. Let me open debug rendering. Okay, first of all, when I press D on my keyboard, the IDE already suggests me data frame. So I can, accept it, run an example, cool, it works. However, there is a deeper thing to it. In R, dot or like period is, you can have this period in the name of the variable or the name of the function. Even more, there is this whole dispatching thing that based on the class, we are using plot dot something to plot something of class something. If you're advanced in R, you know what I mean, probably. In Python, however, you cannot use period in the variable name. Period is an accessor. So we are accessing property of the the namespace. So here we have PD, pandas. Pandas is let's say deployer of Python, and then we are using read CSV function from pandas. Here we are creating path object from this where this file is, and we're getting the parent directory with respect to this path, also by using period. Here, this period, this render is a separate thing. Then we are using dot on this render, and we are getting data frame, which is a something under the render namespace in some sense. The same goes with this shiny.express. So we have Shiny, and from Shiny we are picking express, and from this express we are importing UI in render. Makes sense now, thank you. And that's an important remark for everyone that is proficient in R and is just exploring, is new to Python. This is thing to look for. And usually, if, for example, if I wanted to make a Shiny Express thing, in Python, I would go with underscore here. Is there, okay, so Pavel already answered. Where are Python and its packages available when you run in Shinylive? They're in my browser. The whole Python has been downloaded and is in my browser. Let me check. Okay. I'll do something like, so I'll stop sharing. Hey, by the way, I don't think that you will ask that much about how to, okay, why I should change the interior of H1 tag to get hello world displayed, because I guess that it's fairly obvious for you. But I'm looking for those questions like the one from Kai or the one from Padma Priya. Sorry if I mispronounce it. Yeah. I've opened the console, and as you can, I want to find the PyShiny that has been downloaded. Wait a second. What if I... Okay, so it's cached on my disk and I don't know how to run a fresh run. I know you can barely see it, but you can see here that, for example, NumPy has been downloaded and Pandas has been downloaded, and other Python things like NEIO or typing extensions, or actually Shiny 0.81 has been downloaded. So they all are being downloaded to my browser, and they are executed in my browser, and that's where Python and its packages are available. I'm not sure if it makes sense for you, but I encourage you to read more about Shinylive. It's a very interesting concept, and it opens a few new ways of doing things. Yeah. Okay. Is a render a class in PyShiny? Tom, could you say something more about the question? And I will, because I don't think that they understand it fully. And I also answer John's question. Can I connect to a database using Shiny Express? So if you use Shiny Express, then without any problem. Shiny Express is a way of building up, like here, data frame. So as you can see, we've just used this render data frame, and it feels just like Streamlit because I haven't defined the UI and the server. We'll see more advanced example of Shiny Express in a second. But under the hood, it's just like Shiny core. However, I guess that you might be asking, John, about Shinylive and how to connect to database through Shinylive. And then that's a much more interesting question, because you have to send credentials to this database to the user, because the app is running on the user's machine. I either direct credentials to the database or maybe some token or something. So this user can access the database. and that is living somewhere else. And this thing is, in general, is much trickier to work with. If the app is not living on the server, there's no server that you trust, so on. So in principle, you can, but if you want to connect to the database, you might need a more advanced architecture of your app, and probably you don't want to use Shinylive for that. And then you should use like classic Shiny, PyShiny or rShiny. And if you don't connect to some database, then you can use the Shinylive. I'm not sure if it makes sense. I'm looking forward for more questions. Can we go through through exercises? Exactly. And quickly for Khalil, obviously you can use SQLite database or DuckDB database that's on your machine. However, remember that, because I see a lot of questions regarding Shinylive and Shiny Express. So before we go through exercises, Shinylive is a way to run Shiny applications without any server. So those applications are running inside the browser of the user. You can think about them like just like some website that you go to and something. No, maybe not website. Yeah. So Shinylive applications will work even without the internet in general, provided that you have cached Python and everything. But if I have, for example, a Shinylive application and I run it in Quarto document and I lose the internet connection, the whole Python and everything runs in my browser, but it works, it stays there. It means a couple of things. For example, that I don't need server to maintain for that, but it also means that I have to somehow deal with credentials and authorization if I want to use some external resources. And it also means that I have to send all the data to the user. And it also means that users cannot interact that easily between each other. And finally, this means that this SQLite database would be of use only for this particular user. It's not like different users can, interact through this database. In Shinylive, if you have regular Shiny application, then you can, users can talk between each other through the database, so to say. And Shiny Express is a way of doing applications like Streamlit, but in Shiny. Maybe I will show this example. Let me open it. Okay. Okay. Now we have two applications. On the left, we have two applications. On the left, you have Shiny core application. So we have a UI defined here and a server defined here. This is Shiny core. This is Shiny Express. And in Shiny core, it feels and looks just like regular are Shiny in some sense. So you also define the UI and you define the server. And there is some reactivity that will go in a second. However, in Shiny Express, you don't have this UI defined as like a separate thing, but you are defining UI on the fly. So I want to have some title. So I'm putting title here. Then I want to have some input. Then I want to have some text. Okay, so I have this text. And then I want to have some data frame. And I have this data frame. And maybe this will answer once and for all what's the difference between Shiny Express and Shiny Core. These are different ways of writing Shiny applications. Both of them resulting in the same Shiny applications. And both of them can be used for Shinylive. So you can turn Shiny Express application into Shinylive, so application that runs without server, and you can take Shiny Core application and also make it Shinylive, so it runs without server. Cool. Is there a question that you would like me to answer before I go? How do I install Shiny Express? Please Google Shiny Express and you can, or Shiny Express and Shinylive. Shiny Express is available in regular Shiny for Python, and Shinylive is installable with another package called Shinylive. Cool. Okay. We had this detour. I'm more than happy about this detour. And now let's come back to the examples. Let's go quickly through them. Yeah. So to get Hello World application, we create a h1 tag and we fill it with Hello World. And if we run the application, it shows Hello World.
While we're here, I wanted to highlight there was a question in the chat. How can you create HTML using Shiny? I think this is the preferred and the recommended way. So you can basically imagine you're writing HTML code, but using Python. And you can call h1 to create h1 tag. You can call div to create division tag. And also each of those tags can have args or kwargs, should I say, parameter. So you can add style equals something, on-click equals something. So you can basically create your HTML code. You just write it using Python, which is very similar to how you do this in R.
Mm-hmm.
So as Pasha is typing, as you can see, the IntelliSense, the code suggestion, has args and kwargs, which is arguments and keyword arguments. And args is basically children of this element. So you can, if your argument is unnamed, it will be treated as a child. So p paragraph is a parent element, and it will have children.
Please help me, our dear full stack developer.
Don't use curly braces, and don't use font. It's just color.
Yeah. Thank you very much.
My full stack development honor is safe.
Exactly. And that's the preferred way to do it. Obviously, you can give this color. You can give some ID to the div, and then you can change this div through some CSS, or whatever you're using for your styles. Yeah, I hope this answers the question. Rendering, yeah, we already went through this data frame here and why it's underscore, not a period. And here something's wrong. And yeah, we got this error. Okay, so render plot doesn't know how to render object of type class data frame. Consider either requesting support for this type of plot object or blah, 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 blah. Actually, we see that, oh, we are using render plot and we should use render data frame to render data frame. Then it works. Adding filters. Okay, so now it will be a bit more advanced. The app that we want to end up with is hello penguins, and we can sort what happens. Nothing happens here. But we'll make something happen here. So we want to add a slider. And if you want to add a slider between the h2 tag, so this hello penguins, and the data frame, this data frame, we want to add it here. And I go UI, this will be a slider, and slider is an input, so I type input. And I can go, oh, it will be an input slider. Input slider text ID. Mass. Okay, this will be minimal penguins mass. We'll have a label, and this label will be displayed next to the slider. So we'll have minimal penguins mass. We'll have minimal value 2000, maximum value 8. Okay, I messed up those, and value 6. Okay, and something is not okay. Anyway, hop. Okay, so let me check. Where is no comma? Okay, I don't know what happened. Anyway, we have a slider. And now, this slider hasn't been connected to anything so far. So we don't have, so this data frame is still displayed the way it was. We can see the columns of this data frame, maybe just by putting the df columns, penguins. So we have this penguins that is a data frame, and in pandas, to get columns, I can use data frame period columns. It's not working because I have to change it to string. And we have those columns, and we have body mass here. And I want to filter those penguins to only have those that have body mass smaller than max. Body mass larger or equal min body mass is input dot up. This syntax might feel weird for you. Okay, a few things. Works. Yeah. So don't worry about this syntax and why, for example, there is this ampersand here. This is because of pandas, and this is how you can do things in pandas. You can do them in many other ways. Let's not focus on this. What I would like you to focus on is that, for example, when I wanted to put string with something in this part of the document, I've used it with just UI.p, and we have this object displayed here. Another thing, mostly for our users that are not that proficient with Python, probably you would use something like call names of penguins. And this is more like functional approach that is used in R. And in Python, we use much more of the like OOP approach, so object-oriented programming approach, and that's why we are using this period here. That's something to look for. So very often you will switch like from this kind of syntax to this kind of syntax. Okay, and then I wanted to refer to the input here, and maybe let me do it here. So try to access input, but it was not imported. Perhaps you need from Shiny Express import input. Yeah, that's exactly what I need. Cool. And then this table shows some summary, but only of penguins that have minimal mass of the slider value. So there are no penguins of mass higher than 6363. I get you get what I mean here. Add the plot. Okay. So this is what we want to get. So we have some simple dashboard based on we can select mass of penguins here, and we can add trend line to the second plot. And if we take a look at this dashboard in the problem section, we actually don't have the second plot here, and we don't have the checkbox. But we have plots.py function file, and if this is this plot, this is probably a scatter plot that we have to add. So we have to import from plots, import this plot and scatter plot. And now, an important thing for everyone that is not used to Python is that the same way that we are importing libraries that are installed in our environment, so we are using pandas, and pandas is something that you have to install. Shiny is something that you have to install. Pathlib is something that is built into Python already, and you're using it the same way. And also, if you have file in the same directory that other file, you're importing functions and things from this file from x import y. Yeah, John, please come back with this question in a second. Now, this is with UI sidebar. This is the way you can write applications in Shiny Express to have sidebar. It's really neat. It's great for prototyping. And let's add checkbox here. Trend line, label add trend line with default value false. Okay. So we have a checkbox here, and now they wanted us to render additional plot. So we want to render one plot below this one. So we run render.plot def. Okay, let's call it scatter. Yeah, we have to copy penguins once again. filter them, and return the scatter plot. It takes 2 parameters, data frame, so this will be filtered, and a trend line, which will be true or false, and it will be our input dot how it's called, trend line. Cool. I hope it works. Yeah. So we've done the exercises. The code is getting erased. Yes, it is. It's because you're running it in this editor in the browser. For, let's say, regular development, I encourage you to set up Visual Studio Code, or I think in RStudio can also run PyShiny applications, but probably VS Code is more like I would advise it. I would advise to use VS Code for PyShiny applications. And I can even say that folks from POSIT also said, like, in their tutorials, they use VS Code for working with PyShiny applications, so it's not that weird. Now the question from Samuel: how do I import data into Shinylive? Can I read CSV or Excel from my local drive? No, you cannot read data in Shinylive from local drive, because this app lives in a separate container, so to say. And it's for a very good purpose, because you don't want to enter some website and then this website can read all your files on your disk. Because let's imagine that it is possible to read files from the disk, from the Shinylive application. Then it would mean that if you go to this website, it would have like power to read things from your disk. You don't want to do this. However, what you can do is to, maybe let's even do it here, or maybe not, because I'll fail. You can upload data to the dashboard. It may sound weird that you want to upload data to the dashboard that is running on your machine and without any server in some sense, but it makes sense, and it's the way to go, because this way I explicitly say I want this file to be uploaded to this website, and I can be the only one to blame if I share my confidential data with the website that I don't trust. I hope it answers your question, Samuel. So can we go to the next section, or you would like to ask about something regarding those examples? Depends. Another question is it possible to share or collaborate on Shinylive with our colleagues? I don't know what you mean, so maybe please rephrase the question. Can you work on the same code, just like, you can store code in Git? Yeah, please rephrase the question. And so it's a question whether you can work on the same code base. And some, folks probably also older than me can say, oh, back in our times, we were using Tmax for multiple users editing the same code through sessions, blah, 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 blah. Nowadays, you can have, for example, live share extension for VS Code that allows you to edit code more or less like in Google Docs. So in some sense, it's working on the same code. But to have a good answer, I would recommend you to have some version control like Git, and then work this way on the shared code base. Reactivity. Now, how does the reactivity work in Shiny applications? So, for example, when I click this at trend line, yes, obviously, like Octavio, the website will be still here probably forever. Is it possible to get snapshot? That is, I can get a static version of the outputs with the inputs. I don't think I understand what you mean here. Now let me maybe focus on the presentation for a few minutes, and then we'll come back to questions in the chat. But I'm very glad that you're asking those questions, because that's the most valuable thing that you can get from the workshop. You can go through all those examples in your time at home, but you will not be able to ask questions to us after the workshop. Can I define reactivity? Yes, so reactivity is that we have this dashboard, and I click here and trend lines disappear. I move this slider and data changes here. So based on some inputs here and there, some outputs change here. And for example, when I change this slider, all three inputs have to change, because they all depend on this filtering of the mass. However, when I toggle this at trend line, only this plot changes, because those two don't depend on the at trend line. And we would like our framework to be aware of that, to know when to re-render part of the dashboard and when not to re-render part of the dashboard. Does Reactive work with text inputs as well? Yes, it does. And because of that, you want to use a special trick, and you will use this trick in the exercise session that will come after this presentation. How Shiny did that? We told Shiny what to do. We didn't tell Shiny when to do it. What do we mean by this quote? If we come back to this example, maybe let me open this in another. Yeah, let's blah blah blah. Okay. So if we come back to this example, you can see that we have some slider and we have some checkbox, right? And when I change this slider, outputs change, but I don't have any like on change attached to the slider. It's not like, okay, when I change the slider, you should do this and that and that. There's nothing like that in Shiny, and that's a thing that differentiates Shiny reactivity approach from, for example, a React reactivity approach, or Reflex, or Dash, or many other frameworks. We are telling Shiny that to re-render the table, we need input mass, for example. And it's up to Shiny to discover when this input changed. And if it changed, then we have to re-render the table and so on. I know it's it might not make any like difference for you. Okay, like it changes, so it changes. But it's key to understanding how reactivity in Shiny works. And I believe that with each, like each sentence from me, you will get like better and better understanding of how it works and why it's important. So the presentation. How do other frameworks work? In Streamlit, we re-render everything everywhere all the time. So if we would change one slider, you're re-rendering the whole application. We'll see an example of that after exercises from this session. Then it also means that sometimes you don't want to re-render everything all the time. So Streamlit folks introduced mechanism of caching. So you can cache some value, but then you have to invalidate the cache and make all sorts of problems. In Dash Planner Gradle Reflex, you define callback functions. So you say, okay, when this slider changes, please do this. When this checkbox changes, please do that. In Shiny, we approach from the other way around. So we say, when you want to render this plot, look for this and look for that. And then we will figure out, okay, so this depends on A and B and so on. So event-driven programming, like in those frameworks, it means that yeah, you have to do it. Many people say that it's easy to get wrong and hard to tell when you've gotten it wrong. And it means, once again, that to my slider, I attach some function that will be executed when this slider changes. So a different way, a better way, a Shiny way is to infer the relationships between components and build computation graph. And we will go through such graph and you will understand perfectly how Shiny works. Trust me. Does Shiny infer relationships by analyzing the source code? No, it doesn't, because it's very hard. And sometimes you want to break the reactivity because, for example, you have text input. So, because we want to have it like, 100% reliable, when each output is being rendered, it's looking for things that it depends on. And we'll see how it's how everything is getting invalidated in a second. Yeah, we have on those slides that folks at Shiny have a lot of years of experience of creating Shiny and how it works, what are the pros, what are the cons. So yeah, that's also an important thing. On one hand, PyShiny is just like our Shiny, but it's like a refactored version of our Shiny. So they were able to get rid of some things that they didn't want in our Shiny, but they had to keep in our Shiny for the legacy reasons, because a lot of people depend on our Shiny. And in PyShiny, they could clean up some little things here and there. And that's obviously a good thing. So it's not static code analysis, but it's runtime tracing. Originally inspired by some JS library, blah, blah, blah. We'll have a better explanation of that. Maybe let me just go through those slides and get to some cool things. With Pavel, we're not convinced with the pictures from the two previous slides, so maybe let's not comment on that. Okay, we have this application. Yes, we have three things here. So we have a table, we have some plots, and we have one slider that is one input, and we have add trend line. And maybe let's focus on the table and on this plot. And now we have a checkbox and a slider. And I don't know why they are rendered this way. I can't help it. So we have checkbox and a slider, and we have scatter plot and this plot. And this plot depends only on slider, right? And scatter plot depends on both of them. Yes, because this plot only depends on the slider, and this plot, so scatter plot, depends on both of them, because if I change In this checkbox, it also changes. And now, let's say that I want to render scatter plot. And now I'm running scatterplot function, and I'm looking for things that it depends on. So, okay, I see that, okay, scatterplot depends on a checkbox and a slider. And I want to render dist plot. So I check on what dist plot depends. Okay. And now this is the reactive graph of this application. And now let's say that slider changes. Now, please focus. That's crucial here. So when the slider changes, right, we are invalidating all things that depend on the slider. So we say that, oh, right now we have to re-render both scatter plot and the dist plot, because something that they depend on changed. So we forget dependencies of scatter plot and we forget dependencies of dist plot, and we are getting them once again. And now let's say that checkbox changes. So we are forgetting that we are invalidating only scatter plot. We are forgetting its dependencies, and we're getting checkbox once again, and we are getting slider value once again. And that's how reactivity works in Shiny. Any questions? Okay, I don't see any questions. I hope you understand it. If you understand this, it will help you really a lot in analyzing all your Shiny applications. And by Shiny, I mean both RShiny, PyShiny, Shinylive, Shiny Express, RShinylive, all Shiny. All Shiny apps works the same way. This is the core principle. These are the core principles of the reactivity.
Pasha, please wait a second. I noticed that we have people who are probably willing to ask their questions with voice. So, Alexis, I will try to approve your request. I think that I was able to see your request because you requested to talk. If that's true, please do. Otherwise, maybe I'm wrong.
Okay. So let me answer two questions. First, question from John. It seemed like to make big difference for large apps, but doesn't make difference for smaller apps. Is this just a scale benefit? Definitely not. And we'll see an example where it really matters. And by the way, so people argue whether this like Shiny approach or React approach is better in terms of how to write code, how to maintain the code. And I can understand both sides, and sometimes there are cases where it's nicer to have a reactive framework where you have, I'm just asking for things and like get me this input. And obviously we haven't seen it yet, but you can also create some intermediate state, and we will get me this filtered data frame, and I'll get this filtered data frame. So, and there are also cases where it's better to define on-change callbacks. Yeah. What is not arguable is that Streamlit's approach, so to re-render the whole script every time, is just not scalable or maintainable in any way. It just works for very simple apps, and in case of slightly larger apps, it already breaks. And we'll see like a larger app of 10 or 15 lines where it already breaks. Do you recommend to build a reactivity graph when you're making real apps? I would say that if you're debugging the application, maybe it can help to understand, okay, what changes when. Then yes.
I would say here that it's a really useful exercise to draw those graphs by hand, especially when you start with Shiny. It will teach you that your app looks complex and you need to move reactive parts out of it, and we will get to that in the scope of this workshop as well.
Yeah, true. Cool. So every Shiny app uses this pattern, works for dynamic UIs. Shiny is lazy. So by lazy, it means that only when you're requesting some output to be generated, it is being generated. And let's say that I have two tabs in my dashboard. And in the first tab, I have some data analysis, and in the second, I'm running a different data analysis. So if you open the first tab, Shiny doesn't render the second tab, right? So it's lazy in this sense. It will wait until you click on the second tab, because maybe you have 30 tabs, and you only use 3 of them. Then it doesn't make sense to re-render everything all the time. In that sense, Shiny is lazy, and that's a very good thing. Reactive calculations. Yeah, in examples that we've seen, each input is passed to a rendering function which produces an output. But I've already touched it. Sometimes you want to have an intermediary step. And reactive calc is created for this purpose. And that's intermediate nodes to the reactive graph. So for example, we have this part of the application. So we are rendering table and we are rendering plot, and for both of them we want to have some sample. So to sample input and rows. This one means that we want to have just one number, so we want to sample and rows. And we want to have a data frame with that many random numbers, random values. And here we want to have histogram of those numbers. And there, like, one thing, you have code repetition, and it's probably not good. Usually, if you have code repetition, you want to wrap it in function, but it's also something much more deeper here, and probably most of you already said that, well, we are rendering 2 different samples from, we are sampling 2 different samples, and we are presenting them in data frame here. And then we are creating some plot, and those are different samples because we are running the random function twice. And yeah, those are the same things that I've said. And if you move this to the outside function that is tagged with the decorator reactive calc, you have sample df, and you use in the render table, you return the sample df table, and in the render plot, you're using sampled df function. You have the same sample here and there, and that's actually the thing that you want to have. So once again, what's important is you create another function. This is just a regular Python function. Yeah, for people that don't have any Python experience, def is like function in R, so we are defining function that way. And this function, for example, like no arguments, but good. And this, we are marking this as reactive function. And then the Shiny knows what to do, and like when one thing changes, it knows what to change further. Exactly, and it's also, it caches its value, so it's cheap to call repeatedly. Nothing really crazy here. So now when we have table and plot, we are asking for a sample, and this sample depends on slider. Then when we calculate plot, we get sample, and we already know the value of the sample, so we don't even have to go to the slider, because sample already, we already know how to create sample. And when the slider changes, we say, oh, sample is not valid anymore, so we invalidate the sample, and now sample tells table and plot, oh, folks, you've been invalidated because I don't know my value anymore. And now, because user sees both table and plot, they have to recalculate the table. So like the Shiny has to recalculate the table, so it asks for sample. Sample asks for the slider value. It gets it. So now we have the sample value, and now we want to recalculate plot, because the plot is also being visible in the app, and we get the sample. I hope that it makes sense to you now. And sometimes we want to overwrite reactivity. And what do I mean by that? Just like someone in a chat mentioned, Khalil mentioned that if you're typing text in your application, for example, let's say that I'm typing my name, and I don't want Shiny to rerun on every keystroke and update the like classic example, like hello Pasha on every keystroke. So hello P, hello PA, PAS, PASZ, and so on. What we actually want is to re-render it maybe after I click a button. And that's what we have explained here. We also don't want to, we don't want to run database queries just because someone type just one letter. We want to run database query probably only after someone pressed the button. Query database. And so on and so forth. And we can use reactive event to explicitly specify what should trigger recalculation for an output or a calc. And this is this example. So if I write Pasha and I click enter, only then I see Pasha here. If I now go Pavel, enter, works. But it's not being re-rendered on every keystroke. And how we achieved it? We defined input action button. We'll see it in the exercise session. But we, in this render text, we specified, oh, by the way, you want to render text that matches this ID, but you don't want to render it every time. You only want to render it when you have this event. And it overrides implicit dependency detection with an explicit trigger. Yeah. And maybe how we want to proceed. So it's nice to think about rendering things as like sometimes it's important to notice that this reactive event breaks our reactivity in some sense. And by that I mean that no, you have some manual inputs here and there. And it changes the way the information flows through the app. Maybe let's not say more here. Sometimes it's also nice to think what are side effects. But by the way, we've learned how Shiny renders elements, how Shiny dependencies between inputs and outputs, that you can introduce some intermediary steps with reactive calc. You can explicitly control reactivity with reactive event. And is that enough? I know what they meant by this. Shiny has a function UI show model, which triggers a model window. Okay. And now, how can we call this function? And the question is, because it's not like we have some thing to render. We want actually to have on the button press, you want to run something else somewhere. So the debate is between return values and side effects. So inputs, outputs, and calculation produce values because you have some input and it outputs for example, the slider value, and based on this slider, you can something else and something else, something else. And you can push them downstream and so on. But sometimes you want to execute some code that doesn't produce a value, just like this model. We call it side effect because it's not like we don't need this. We don't have like model that is, that is being rendered. It's only happening once I press the button. So it doesn't fit neither the calculation nor output and how to do it. We can have a reactive effect. An effect is something that is outside of the computational graph, and it's like effect of some event. And reactive effect allows you to have this kind of effects like this model. And usually paired with the reactive event, because based on some button you want to have some thing. And an important rule is that code that produces an output is always marked with render something. If it produces an intermediary value, it's reactive calc. And only the one with side effects is reactive effect. And if code produces a value and a side effect, you shouldn't do that because it makes much harder to think about your reason about your application. So for example, you shouldn't have function that at the same time displays the plot and saves data to a file. Because saving to the file is like side effect. And you want to have this extracted into a different function that runs under the same circumstances that this display plot, for example. I guess that you will get more of a feeling of this concept in a second. But maybe now let's go through some quiz. So writing a CSV is a value or a side effect. It's a side effect because it's not like we're getting anything from writing CSV. Querying a database. If we're querying, we are receiving something, so it will be a value. If we're adding two numbers, then we are getting some value, so it's a value. And this is an interesting one. If you print something to the console, it's also a side effect because you're not getting anything from this console. And fetching current temperature from an API. Even though it's like you're getting somewhere else, so you can think, oh, it's on the side. It's a value because you're getting the value from the API. Function that source lists in place. All the in place operations are like side effects because you're not getting the result of the sorting, like it's happening on the side. Getting a model score for a set of inputs. You have some inputs, you're getting a score, you're getting a value, it's a value. Deploying a model to a hosting service, you're not getting anything. You're doing something on the side, like take my code and put it there. It's side effect. Of course, probably if you deploy the model, you will also get the link to your deployed model, but the deployment is actually a side effect. Cool. Is one way to use model by showing an error message if a user enters an incorrect text value. Okay, maybe let me finish the slides and we'll go to exercises. So what's the side effect? This is side effect. Now, let's go to exercises, and I think that we deserve a break because this was supposed to be 4 hours with breaks, and we definitely need one. So now I leave you with exercises for reactivity, and I propose to meet in 15 minutes. So depending on the time zone that you're in, it will be something 53 or 23 if you're in India, I guess. And please prepare in the meantime your questions, get some water, get some, exercise a bit to regain your focus, and we're meeting in 15 minutes. Hey, I'm here already, so I can answer questions. In the meantime, I've created a pool. We'll pause with, in detail things until people come back from their break. If you have any question, feel free to write down in the chat.
Well, I think we have a question regarding R. So, Adrian, in your particular example, I don't think there is a need to include IPyLeaflet through Reticulate because we have leaflet in R, which has very, very nice bindings with Shiny. It has proxy object, it has output, it even has input. So when you click on the map, you can get longitude, latitude. Arguably, in my personal hands-on experience, leaflet in R is much, much better than IPyLeaflet in PyShiny, because IPyLeaflet was created before PyShiny. It's meant to be used with Jupyter Notebook, right? I can also, again, see people in moderation. So maybe I will try to accept a few things. Maybe we can have somebody here.
Yeah, if they want.
Question?
I've seen that one person joined and then they disappeared. So thanks for not breaking the workshop and not saying some bad words. Yeah, if anyone wants to ask a question like with their voice.
So we have a question from Tom. What are some of the key differences between Shiny in Python and Shiny in R? Which is an interesting question. In my opinion, the differences between the Shiny itself in R and Python are, well, they exist, but they're not critical, I would say. Shiny for R has been around certainly for much longer time. So one of the differences is the community. Of course, if you have problems with your app, with development, you can more or less easily find answers to your questions regarding R Shiny, but not PyShiny, simply because it's been around for only a year, maybe two. Another difference is the Python ecosystem. I think this is a big one. You get type hints, you get build tools, dependency management, asynchronous programming, context management, decorators, everything that Python has, which is good about Python, it will be good about Shiny for Python compared to R Shiny.
Exactly.
And I would say that the third section of differences is, as Pasha mentioned before, because PyShiny was created recently, the developers who are the same behind RShiny and PyShiny, they had a chance to refactor their ideas, their APIs. So some function names are a bit different. For example, in the previous lecture, Pasha was talking a lot about reactive calc and reactive effect. We have that in R, for example, as a reactive or observe event or observe. However, reactive effect and reactive calc, clearly communicate the intent behind them. What should you expect as a developer from this computation? Should it return something, or should it produce a side effect and maybe print something, or open a model, send a notification, do something else, etc. So I would say slight API changes in the package itself. Also, you notice that there is no camel case, everything is snake case, very nice. And in RShiny, you would notice that, especially when you use different packages, that some packages follow camel case notation convention, some follow snake case. Even base R itself has different notation options, including Pascal case. But, well, that's not what really matters, whether you use underscores or not, but your names of functions help you as a user to find something that you're looking for. So, for example, you could notice that when you're looking for an input, so when Piotr was looking for slider input, he just typed input and started scrolling through the suggestions, because that's how function names are organized. It's not slider input, action button, text input. Well, I mean, it's a subtle difference, but it matters a lot for developer experience, because to find verbatim text output in RShiny, I have to know what I'm looking for. And here in PyShiny, I can type output, and I am suggested, I can see those options, what I have available to me. So I would roughly divide the differences into these three categories.
And I agree with them. Hello, hello after the break. There was a question that Paul was answering about the key differences between RShiny and PyShiny, and you can listen to those differences in the recording later on. There was a question from Emmanuel, how to deploy Shiny applications, and you can deploy them on Connect. You can also check out the Shiny for Python deploy section of the docs. Hop. Yep. Regarding the exercises. So we've covered the reactivity. Now we'll go through the exercises, and as I see from the poll that I've created, then we'll go through the UI and about the Python ecosystem, and at the end we'll take a look at the comparison with Streamlit and Dash. They are already in the repository, so maybe maybe not. Yeah. Let's go through the exercises. So what's the goal? The goal is to extract the reactive calculation from the app to reduce repetition and speed up the application. So we see that we have some UI. It's already getting, a lot of indentation, right? So in the next section, we'll think how to tackle this issue. But we see that, okay, so we have some. Oh, yeah, by the way, previous apps were in Shiny Express, and we were writing, okay, we want to have with sidebar something, or we want to have panel title something. And now you can see that we have some app UI and we have page fluid. And this is the way you were probably writing things in RShiny. And we wanted to show to you like both approaches in this workshop, so you're familiar with both of them, and you can see that the vast majority of things are the same. And it's very easy to convert Shiny Express application to core application, to Shiny core application. I don't see a use case where you would like to go the other way around. You usually want to experiment, prototype with Shiny Express, and then turn it to something more scalable with a Shiny core and easier to maintain in a long run. So have this in mind while doing those exercises. And just as Pavel mentioned, all inputs, no matter whether it's a numeric input or slider or selectize, they all start with input, and the same with outputs: output plot, output text, output data frame. And what we can see here is that we are sampling data in multiple places. So maybe it's actually, so we are sampling different data actually for this mass plot and different data for this data frame, and different data for this row count. And the way it should be done is reactive calc. Yeah, so folks at POSIT on one hand tried to fix a lot of things, and for some reason I don't understand it, but we have calc with capital C and with lowercase c, and they're the same. Yeah, so let's def a sampled data frame, and sample data frame will be this data frame. We'll return it, and everywhere where we are using this, we'll be using sample data frame. Remember about the parentheses, because it's a function that we want to call. Now, okay, and if I run, okay, let's try to run it, and let's see. Okay, I don't know what this is. However, the example works. And yeah, and now we're getting the same rows. It doesn't work. Why? The plot looks the same. Something is off here. Something is off. So yeah, and then maybe, but it shouldn't be.
What if you try reactive calc with capital C? Just in case.
Fortunately, it still doesn't work. No, this updates, but for some reason this plot or maybe it took just so long for this plot. And if we change this. Anyone has any idea? Maybe in the column, in the chat. Plot is independent of mass. No, it's not independent. Oh yes, plot. Okay, but it's dependent on the sample size. Great, perfect. Thank you, Marius. Yeah, so I've changed, when I change the sample size, then I get everything re-rendered. Point for you. Exactly, so everything works as expected, and let's, for like, just to be sure, let's run it with lowercase c, and it still works, but for some reason it looks like it's, I think that in this version of Shiny there is something messed up with the types of things with lower c, but I don't want to be, don't take my word for granted. Okay, let's go through questions. And okay, question from Emmanuel. If we run those examples in VS Code, where those outputs will be. So please check out the Shiny for Python extension VS Code. Check out this extension. And this extension helps you writing Shiny for Python application in VS Code, and you have little browser in VS Code. Obviously, you can also have run this Shiny application. We'll run them from VS Code later on, just like regular application. And answering Nicolas' question, now you have to manually convert the applications. Maybe in the future, they will introduce some automatic converter for Shiny Express to Shiny Core application, but I'm not aware of such thing. So answering Simon's question. So reactive calc is being auto-suggested with parentheses, and then I have to remove it. I don't have to remove them. They can be here, but they are not necessary. That's because reactive calc is a function that takes only one parameter. And this is this function because it's a decorator. I know it might sound like mysterious for you, but I encourage you to read what are the decorators in Python. Usually they are not they're not the first things that you learn about Python. You first learn about functions and maybe classes, and decorators come only later on. However, understanding how they work is very helpful for understanding that there's no magic. Like it's not nothing strange here. And now let's go through. Okay, so and another exercise: draw a reactive graph of above application. Maybe let's skip this for now. Let's go to reactive events, and now we want to add input action button to the app. So because right now, if I type anything here, it's already being consumed, and we are running the whole reactivity here. And we would like only to render this text once I press the button. So first I want to add a button with UI. It will be some input, and it will be input action button ID. Display text, display text. Okay. One very useful and very little thing in Python is that, for example, you have multiple elements, multiple arguments of this function. This, that, and that. This, and that. And notice that you can have a trailing comma here. And that's how the Python is defined. If I omit this comma, obviously everything works, but I can add this. So for example, when I add a new row, I can just edit this row and I don't have to put comma here. Very minor thing, but very useful. And it's very, I can even say frustrating if you're, when I come back to R and I have to code something in R, and then I catch myself having to remove the trailing comma because it's so natural for me. Anyway, we define the action button. We can run the text. Okay, display text. It's being displayed automatically, right? Because we haven't added the reactive event. Now we add wall. Okay, reactive effect. No, not event. And now this event is the input display text. Hop, run. Hop, display text. Works. And now question, what happens if I misplace the reactive event thing? We get an error. And if I try to run it, the app crashes, and this will be the error that I will get. So if you have this kind of error, you have to switch the render text and reactive event. So first you have render and then reactive event. I hope no surprises here. And regarding reactive effects, so what do we have in this app? Yeah, sometimes you want to be able to reset the slider or your inputs in general, and it means that you have to change this slider somehow. And for that we have update asterisk functions. So let's first we have to add next under this slider. So we have this slider here. Here we want to add action input action button reset slider label reset slider whole. And now we have to the button is already there, but we have to bind to this slider. And now I do reactive effect. So I have to import reactive effect. Hop, hop, hop. Okay, so I say that I have reactive effect, and it will be triggered by this reactive event. That depends on the slider. I can use underscore as a name of this function because it doesn't matter what the name of this function is. And now I have to update the slider, update slider. The idea of the slider is mass. And I update it with the value, maybe even let's write here, div mass slider value, hop, 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 hop. And now, I get it might not be that, ground, like breaking through things and so on. But an important note here regarding the reactivity of Shiny apps. Now look that we've changed the slider value through this event. And we don't have to say, oh, if you press this button, you have to re-render the table because now the mass could change and so on. We just say that the mass changed. And because mass changed, Shiny knows that this table depends on the mass slider, and because we invalidated the mass slider with this reset slider, now the table has also to be re-rendered, and that's a powerful feature of reactive programming. Okay, can you relate difference between value and side effect we discussed just now with this exercise? So yeah, like side effect here is because I don't use the output of this functionality to do something else. I am just resetting the mass, period. I'm just changing the slider value, and that's it. I don't care that something else. I don't return anything. It's like I don't return here anything. So that's why this is side effect. And in a previous exercise where we were extracting this sampling data that I was fighting for, and Marius helped me to debug the case, we were calculating something, and based on this sample data, we were using it in multiple places of the app. So that was, we were getting value from this function, and that's why it was reactive calc. And here we have reactive effect, because it's just an effect, and it's up to Shiny to know that, oh, because mass changed, now we have to recalculate all the things that depended on the mass. Cool. I'm glad that you get it now. So that's it. Now UI customization. UI customization. So far, we've learned how to build an app, how Shiny render things. The session is about how they look. We're going to cover a lot of UI elements quickly. Why? Because they are very similar to our Shiny. There are no like concepts here, like this reactivity concept, like this side effect and value concepts. These are more like a gallery, and you should just know that they exist. And don't worry too much about remembering how they work. You can just go to Shiny documentation and check them out. Okay, this is possible, this is available, and this is available. Okay, and an important thing is why I care about UI design, because that's what your stakeholders care about, and good UI simplifies your application code. Okay, do we have anything more? No. So I would like to spend a bit, like a minute in this section, because let's say from the Epsilon's perspective, we see that really a lot can be gained by having a better UI. And I think that Pavel, you will agree that it would be like, we really want to encourage people to spend a bit more time thinking about how the application look like, because when you're building an app and you're not a student working, on your side project, but you're in some company, you want other people to use this app. And if this app is ugly or just not that pleasant to work with, because maybe the UI is nice, but the UX is terrible, so the user experience is terrible, no one will use your app, or they will hate to use your app. And you want people to love using your app, because if people love using your app, then it's much higher. It's much higher chance that you will get I don't know, like funding for this app. You will get people using this app, and you will be able to develop new features. And if you're manager of a team that creates Shiny apps, you have much stronger, arguments to convince your managers to do something in the company because of the inputs from your dashboard, from your team's dashboard, only because it looks nicer in some sense. It might be not, you may not want to agree with that, but I think that everyone agrees that there are apps that you want to work with because they have nice UI. And I know if you worked with GitHub projects, they just feel nice. If you're adding an issue and it's also already transferred to displays and it's rendered that way and so on. So I really, really want to encourage you to care about the UI that you design. And Pavel, do you have something to add?
I absolutely agree. People love with their eyes, and when you see a lot of apps every day, UI helps you to stand out from all the other competitors. Yeah, so pretty much what you said.
Yeah. And that's, for example, one of I would say potential advantages of Shiny over Streamlit, because in Streamlit you can't really change the UI of your app. It's very Streamlit-ish and it's well defined. While in Shiny you have much more freedom because you're actually building the application in some way from HTML tags. Yeah, maybe let's go forward, but I really want you to have this in mind, that, well, yes, it's like the UI of dashboards is really, really important. So in Shiny for Python, you can do all the things like that. So you have sidebar, you have some date selector, you have some select eyes, you can have different tabs, and something can be displayed here based on the tab that you're in. Okay, you can also have like clickable rows, and based on the what you've clicked, you can have something else. Yeah, you can have those nice cards. You can have this sliders, and that's basically what's possible in Shiny, but not only. Yeah, maybe let's start with the anatomy of Shiny UI. So it consists of two things. Yeah, in general, UI is separate from the server. It's made up of pure functions. You can break them into objects. You can create them with functions. Yeah. What I wanted to say. Yeah, you can style everything with CSS. If you know JS, you can use JS. Yeah, I wanted to say that there are container functions and element functions. So those are elements, right? Because this will be some data frame one day, let's say. This will be some button slider. This will be title. While those are containers, because this tells me, okay, this will be page, like fluid page, bootstrap fluid page. We'll have sidebar layout, and this will be sidebar, and this will be main, a window. Some layout function can take any child and layout them out in order. So for example, you can pass multiple things to page fluid or panel sidebar, main panel, and so on. I think if you're coming from RShiny, it's not as important. So maybe let's not spend so much time here. You can also use navset tab. It's just navigation with tabs. Nothing fancy. So you have in one tab you have a slider, in another tab you have a button, and in third tab you have a second button. And code for that is we have one nav with the name tab1, and that has a slider, another with tab2 which has a button. This button has ID button and text button with capital B, and the third tab. I think that you get the feeling. Cool. Now I see an interesting question from James. Is it always best to design UI first before programming? I'm curious what Paul has to say here, but I would say that probably you're using Shiny because it has very high you can work with it very quickly, and you can very quickly get nice results. For example, just those 8 lines, and I have 3 tabs already, and button and slider, and I can connect between them in the way I want. So probably you want to iterate quickly, so you want to design some UI and then already add something, like go back and forth. But on the other hand, you should have like a rough idea of what do you want to do, because otherwise, if you're just going into hacker mode without any thinking, you will end up with spaghetti very, very quickly. Pavel?
Yeah, I agree with what you said. I'm thinking that it's hard to answer that question without the context, because if you are a big company who's going to develop a product, you first need to make a user research. Then it's best if you can have a designer who would think about your user flows, how they're going to use the app, what they need, etc. This designer will create some user interface wireframe, and then you can start implementing that wireframe with your application. But if you're in a different position, I find it best, and I think this is where Shiny shines, is you first create a prototype, you see if somebody cares about this. And because if nobody cares, your beautiful design, well, you will spend money on it, but if it's not useful to people, what's use of it? So make a prototype, see how it goes. If somebody cares about it, if people want to use it, but you feel that you're lacking in design, then create a design and implement the design. Like, it has to be iterative and agile triggered, but it depends on the context.
Yeah, definitely. Apart from nav sets, we have also cards, and they are nice for grouping with the UI card. So yeah, this is a card. It looks nice. It's nice for organizing stuff. Then we have rows and columns. And what's nice about, maybe we'll have also. Yeah, so you can define your UI in terms of rows and columns, just as we've seen earlier. We can have first bootstrap grid, and you can say like how wide should be each column, and then like how it should work in each row. Nothing, nothing like spectacular here in some sense. Yeah, what's nice is that it reacts to the screen size, so you don't have to care about whether someone is using, like super wide screen or mobile phone. It should work and scale accordingly. Yeah, but if we have this code, then in 10 lines, we are effectively having only 2 outputs in 2 columns in one row. And then you're like, okay, like why I have to write so much code? maybe you want, maybe you would like to organize it a bit. Yeah, too many brackets, too many indents. So here we see that this UI nav setup, it takes 3 things and combines them. Nothing stops us from extracting those intermediary values to different variables. Whether it's better or worse, it depends on the context, obviously, because sometimes I could argue that this is less clear than this, because here we already see like what's what. But you can imagine that in like slightly larger example, you get like to, I know, 8 or maybe 5 times of like 8 or 5 times levels of indentation, and then it's nightmare. It's hard to work with such code. You change one line and like everything changes, and yeah, it's not nice. And then you can extract UI functions to variables. Then we have something like value box. You can also have dynamic yes user interfaces. So only after I click a checkbox and I click show slider, the slider is being shown. And how can I achieve it? One way is to use render UI, and the same way that you're rendering, for example, data frame or plot, you can also render some UI elements, and you can also use conditional panel, and this will hide things on the browser and will only display some things if the JS code is true. We will see an example of that in a second. Yeah, and you can update the UI elements just as we've seen with the reset slider example. Nothing crazy here. You render UI with render.ui because you have UI output. Actually, not UI output, but output UI, just as we've discussed with Pavel. So yeah, here we have input checkbox, show checkbox, and we have panel conditional. And if this JS value is true, then we are rendering this thing. And we have output UI, dynamic slider. And this dynamic slider, if the show slider is true, but now this is Python expression, we are returning this slider. So as you can see, we have 2 examples of having dynamic UI in Shiny. It's worth to know both of them, so I encourage you to focus on this. So you can either have panel conditional that takes some JavaScript condition, and based on this condition, if it's true, it will display this. Or you can have output UI function that looks like output text, for example. Then you have render UI because you have UI, not text. This ID have to match, and then based on this input shadow input show slider, we are returning a slider. I hope that it's more or less clear for you now. But in general, yeah, UIs can be intimidating. Insert UI with output UI, create rendering function for that. Decorate it with render UI. It's no, but let's not even mention this. very powerful, but the code has to do the round trip to the server, and sometimes you want to. It's nicer to have just hide some things with the panel conditional. And yeah, things to note: this is JavaScript condition, not Python. If you used RShiny, probably you know why. So very often you may want to use, for example, triple equal to check for some equality. Just use JS, just use Google, and it will help you to come up with conditions that you want to check, whether you want to display some UI or not. Whew. That's it for this session. Now we can go to exercises. And I can only recommend you here to use Discord. And I don't know if Gigi is here, but or someone from Posit is here, but you can share the link to Posit Discord. I also take part, I engage in this Discord about PyShiny, and the questions are being answered very quickly, and I really recommend it. Do you have any questions here? I will go through the exercises. Those exercises are, just so you get familiarized with the nav setups and navs and things like cards and layouts and value boxes, dynamic UI. With everyone you have, with every exercise you have also a solution, so you can check whether it's correct or not, or like how the correct solution should look like. Let's do this exercise. So we want to have two tabs, and right now we don't have any tabs. We have slider and plots. Okay, so we already have. What's happening here? Okay, so we have a regular Shiny core application, and someone already gave us those to start working with. So maybe if we so this is an example how we could use UI nav and UI nav setup. So we want to have in the panel main, we want to have data frame output on a second tab. So let's create UI nav setup. UI nav setup, and we'll it will have one tab with those outputs, and the name of this tab will be plots. Okay, and then we want to have another nav with data frame, and we want to put this here. Hop. I'm missing this. And as you can see, it's not that complicated. So I've created nav setup, and I created one nav. The first argument is the name and title. Actually, this already Okay, this is, by the way, deprecated. You should use nav panel. That's fine. The example will run the same way. Sure. So it takes title as a first parameter and then args as a like child. So we can have different childs here. Please ask questions if you have in a chat, and I will take a look at them now. I think it uses Bootstrap 5. I think so, but you can check.
Yes.
Yeah. Is there a way to change the inputs? And what do you mean, Kyle, by that?
So I actually think that by this moment we've learned enough to make that happen. You basically can track an event of input of tab change, and when that event happens, you want to run a side effect to update, for example, slider value. So do you understand your question correctly, that when you open the app, your slider is at 0.5, but when I click to a different tab, my slider goes, for example, to 1?
Yeah, I mean, you can maybe work on this in the background. Yeah, so this is what you can do. I don't want to go through the rest of those exercises. Please go through them yourself. I don't think that they are that meaningful as workflow best practices and the modern Pythonic toolkit. I think that is maybe even the most interesting part for some of you. So, workflow best practices. The goal is to learn Shiny best practices. One thing, yeah, avoid premature refactoring. The thing is that very often I've seen in the past me and other people trying to make the most optimal, the best design something for a project, for a little project, and then in the end, I focus so much on making it like great from the first approach that I've like lost the main goal of why I'm doing this project. And maybe I was frustrated because I wasn't able to write this algorithm in n log n instead of n squared complexity or something. And obviously it's important. It's nice to write things in an optimal way, but it's very often it's crucial to have things also working in the first place. Because if you have things working in the first place, then you can go to your manager and you can say, hey, maybe we should check out the stock of, I don't have more creative ideas, but like, tomatoes at our warehouse, because there's unreasonably high amount of those, and you've done this research, and you've done some data science work. You've created some Shiny app to present it to show that in those previous months you had that many tomatoes at warehouse, and we can make a better use of them and so on. And if you focus too much on getting some things right in the beginning, you might not even come to this place where you have this Shiny app, or even those insights that you should create this Shiny app to show to your boss that, you have those tomatoes and maybe you could make use of them and optimize, many dollars. So yeah, start by just getting your app to work. And if you see that you have some repetition in your code, that probably means that you can extract some things to the function. And this is a very important one. And I really feel like data scientists don't understand it that much because they have very often, they haven't been trained from high school to, to writing code, but more to getting insights. And probably someone else will also work with your code. Someone else will also take a look at your code. And maybe it's a good idea to have some way of preventing of having names like df for data frame in your entire code base, or L for a list in your entire code base. And it might sound very, like very rigid and very restrictive. But on the other hand, like if you're forced not to use name df for data frame, it means that you will think, just half a minute maybe about the proper name for data frame. And then for the rest of your project's life, no one in your team will ever have to think whether it's this data frame represents like sales, or maybe it represents orders, or maybe requests, or whatever, because this variable will be called df orders, for example. And then everything is so much simpler. So yeah. So remember that other people will take a look at your code. When should you refactor? When you have too much to hold too much in your head. And yeah, this is actually a very nice example. So it depends on the country you're from, but in some countries, like for example, in Poland, where I am from, I haven't been taught in my school to write a first version of some essay and then read this and write a next version of this essay. I was always like taught to just write the essay, period. And apparently it's not the best way to write essays. It's much better, and the essays are of much higher quality if you just write the first essay and you don't try to optimize everything and use the nicest words and so on. You just do the brain dump and you write an essay, and only then you optimize. You see, oh, it doesn't connect that well, or later you come up with some brilliant idea how to start the first paragraph and so on. And the same thing applies to code. So just write the code in the first place, but then maybe before you share this code, it's okay to take a look at your code and refactor it. It's okay to take a look after you finish a function and come up with better names for all variables. You don't have to come up with those perfect names from the first minute. And that's something I would like you to have in your mind. Pavel, no, this is a very software engineering topic. Maybe you want to add something here as well.
I mean, I'm not sure what can I add to this topic. You're brilliant. You're correct. Everything's right. Iterative process.
Yes. And it really means that it's okay to have suboptimal solution in the first approach, really. Yeah. So you're trying to hold too much in your head, maybe because you were creating a function and you were coming up with some random variable names, and now you see, oh, maybe I can change this S to requester email, and then I'll know that, okay, it's a requester email. And because I work in Python and I have type hints, I will know that it's a string, so I don't have to even check whether it's string or not. I don't have to include it into variable name and so on. This is also a very important part. So if changing app is difficult, it means that you probably should refactor the app. And other people don't understand your code, and you don't understand your code, then it's definitely time to refactor. three main techniques proposed by Gordon and Zhao is first, to use functions to generate UI. What do I mean by that? It was some MacBook feature anyway. Functions to generate UI, separate reactive and non-reactive code, and to use modules. And we'll touch modules that just briefly. We don't have exercise on them. So in Python, some may argue that functions are the best way to improve code quality. I can say that they are the first thing that you do to improve the code quality. Then you can also create classes and then make everything nicer and so on. Functions are much easier to test than one large thing. Maybe let's go to examples. Let's go to examples. You may have 6 sliders. And you can have code like that. You can also have code like that. So you define function mySlider that takes ID and label. And okay, the label shouldn't be there because there is already n. Sorry. So this function takes only ID and it takes only ID. We are passing ID full. And you can also even write a loop. And now we can define 6 or like 5. There were 6 here, yeah. 5 different UI elements in a loop. I don't say that in this particular case, this approach is better than this approach. Right? So don't understand it like that. But I would argue that in some cases you want to have to extract the things into functions. You can also iterate over 2 lists, so you can have like 6 buttons with labels, first, second, third, fourth, fifth, and so on, and you can use just Python features for that. One important thing is to try and separate reactive and non-reactive logic. Why? Because Pavel, maybe you want to take this. Why you should separate reactive and non-reactive logic?
Sure. I was just writing an answer to a very interesting question on chat, but I can finish that later. I will get back to decorators. So it's actually very simple. Your Shiny app, in the beginning of the workshop, there was a question whether I should or not draw a reactivity graph of my app. And I mentioned that this is a very, very nice exercise because you will clearly see how complex your app might be, how many things depend on each other. And it just so happens that very often you make things reactive where they shouldn't be reactive, or they don't necessarily have to be reactive. So for example, well, in our exercises, we did a lot of data table rendering, which takes some data argument and renders a data frame, pandas data frame, and renders it as a table on the page. And we did a lot of logic inside that reactive. And it's actually a common pattern in Shiny apps, where in Shiny or in Python, you have table output, you want to render it, and inside that render function, you would do all the data wrangling, mutations, computations, etc. And imagine something goes wrong, and now you have to debug it. It can easily become a mess. Instead, what you could do, you can still have that reactive expression that renders a table, but inside of it, it calls a function that does all the processing related to your table, to your data, and then you call this function, it returns processed data, and then you render that data as a table. The benefit for that is that you can now test and debug this function outside of Shiny. The most important thing that you don't have to see what happens when you change inputs. For example, I might sound confusing, but if you have a function that takes 3 arguments, first is a data frame, second, number of rows, and third is a column, you don't need Shiny to see what would happen if you pass certain arguments to that function, right? Which means that you don't have to restart your app. You can write a unit test for that. You can do that in REPL, in Python, in a Jupyter notebook, anyway outside of your Shiny application. And you are always certain what would happen. And then in Shiny code, you just replace those arguments with input values. And now it works as expected. Yeah, I would say that the function filter data should also take mass as a non-reactive.
Yeah, definitely.
Right.
Yeah.
And now this is much cleaner, and it's also portable. Like you can take this function and you can use it in your notebook, in your CLI script, in your data pipeline, wherever. You can, as I hope we will get there, Pasha will tell you about writing packages for data science. So you can have that function packaged and you can reuse your code in your Shiny app, in your data processing pipeline, in your ETL, anywhere.
Yeah. I just wanted to finish this function. I hope that you see where it's coming to.
Sorry if I was confusing. I meant that you can write a function, and to see how it works, you can just start Python in your terminal and call this function with arguments that you want.
Maybe now take a look at this example here. So before we were doing filtering in this table function. So we were messing up the reactive thing and non-reactive thing. So filtering is, it's logic. It's logic that shouldn't be like, it doesn't have to be coupled so much with the UI, displaying UI. And here we extract the filter data into another function that takes just a data frame and mass. And this function doesn't know that it exists in context of Shiny. It could exist in the context of Streamlit, in the context of Django, in the context of Jupyter Notebook, anywhere. And we are using this function to create filter data reactive value in Shiny, and then we are using this here. I hope that it also explains a bit the question and answers the question. Okay. Went through this, and maybe let's go to some examples. If you have functions just like this filter data, you can call them in Notebook. You can write unit tests for them, and it makes your code much cleaner. You can use them in other context, and then modules. So blah, 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 blah. We actually have an example on that. First, I want to put this brilliant Shiny doc from, I guess, from Gordon or someone else at POSIT that explains modules in Shiny, in PyShiny. You may have used modules in RShiny, but you can also live without them in RShiny. In PyShiny, you actually cannot live without modules in many contexts, because when you have this, let me share some example of some application. Yeah. When you have this server function in Shiny, you may remember that you are editing sometimes the output list or variable. You're editing this output variable to get something rendered. In PyShiny, it's not possible because it's only make your code messier, and you're really encouraged to use a different module for things you want to render. This is a bit more advanced, but I guess that there are some people out of this 130 people in the presentation that Pavel, please don't answer James' question.
Okay.
And in Python, you sometimes you have to use modules. So let's imagine this case that we want to have a repeatable UI that will have 2 images. There should be 6, but it doesn't matter that much. It will have 2 images. That's an actual code from app I was building. And for reference image, we're taking some Python object and we take its path. And for segment image, we have some magic here, but what's important, and yes, we are mixing the reactivity and the UI and logic and so on. It's not the best in this case, but what's important is that we will want to, the actual use case was that we have a table with images, and you can select multiple rows of these images. By images, I mean actually metadata about the images. And once you click the row in the data table, in the data frame, those images are being displayed. Actually, pair of images. And the best way to do it in PyShiny is to use Shiny modules. So we are defining the UI part. So each images row will be layout with columns, with two columns. We define a server that takes 3 classic server parameters, but also any parameters that I want to pass here. It can be, I wanted to also show that they can be like any Python object. Those were defined in some other place. And then, just like with regular Shiny applications, we have output UI output image that has to match render image, and the ID has to match. And then in the render UI, we get selected files from the data frame, and we create server for each file, and we create images row for each file. I know that it's a bit more advanced, but I wanted to just, throw this example at you, because maybe you will use it one day, and it may help save you, a few hours to get unstuck. And this is the end of this presentation.
Just before we finish, I shared a couple of links for those who are interested to learn more about modules. to a PyShiny app and the source code for it, where we actually used modules. So you can see for yourselves why and how they're useful in the code.
Nice. Nice, yeah. So maybe let's go through one or two examples here. So we have some repetitive code which creates column with a single card in it. So as you can see, we have those like the nightmarish amount of indentation here, and we also have like this is one column and this is second column, and as you can see, only like this is important in some sense, and all of this is just a boilerplate. Yeah, I think of this. So we want to have an additional function that will generate a column of width 6, or maybe let's specify the with any tags in it that we want. So maybe let's take one as an example here. Okay, and now, well, we want to have the column card. Let's say it takes width of type int that's says is 6, the default value is 6, and then it takes like the and let's say that it's so let's again we have to do it the other way around. And we want to return UI column with and now we want to put child tags here. And this star or asterisk means that we'll unpack this list here. So all elements from this list will be put here, like separated by period. And we want to have a UI card here. Okay. And now with this function column card, we can do column card. I want to pass a list of elements. Hop. And another column card. Hop. 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 Probably like here, and this should work, I guess. Yeah, and as you can see, it works. Is it formatted in a reasonable way? More or less. The point is that, as you can see, now we at least cut some indentation. And then we could also separate the whole panel main definition and panel sidebar definition and so on, and work iteratively on our of the design of our app. So the code is cleaner and nicer, and so on and so forth. Okay. I guess that we can move to this section, but maybe let's take 3 minutes break, because I really have to take a break. And let's meet in 3 minutes, 10 past sharp. Okay, I see a nice question from Steven, and we'll get to this after this presentation when I'll go through those through the code actually in VS Code. But yeah, we definitely would like to answer it. Yeah. So maybe let's start with it. That's a very good point. That in R, if you want to create a dashboard, if you want actually to share, if you want to share your results, the only way to do so in R is either you're creating a RShiny dashboard or you're creating some R Markdown Quarto document or dashboard, right? But there are no like many, frameworks for like web frameworks in R. In Python, you have plenty of them. So you have some full stack frameworks like Django, Flask. You don't look that in Flask, for example. You can just write an API like in Plumber in R, for example. Yeah, there's Plumber in R that you can also use to share your insights in a nice way. But there are those frameworks like Flask, Django that allow you to create the whole application. Like, it doesn't have to be a dashboard. No one thinks about like Django that is for dashboards. It's for web development in Python. Then you have some other frameworks like Streamlit, Dash. You have Reflex that are also for doing web pages, or especially when it comes to Streamlit and Dash for doing dashboards mostly. And then you have also Shiny here. And now the question is, which one you would like to use? Whether you would like to use Dash or Streamlit or Shiny or Reflex, and we have examples on that. You can find them actually already in the code. Maybe I can share the link to the code for this workshop once again here. And in the comparisons, you can take a look at the code, and I'll go through those examples in a second, but I really want to have this presentation on modern Pythonic toolkit, because I think that it might be useful for everyone. And by everyone, I mean, even if you're here just for, I want to have a glimpse of what's RShiny, what's PyShiny. I don't think that I will code in PyShiny in like the nearest future. We're working in RShiny, and maybe I will switch off for this part of the presentation. Actually, I would encourage you to actually focus on this part of the presentation, because it might show you what is possible in Python. Maybe I will refer it also to other technologies, because it's nice to see that some things are just not possible in one ecosystem and are taken for granted in another ecosystem. Pavel, would you like to add something?
Sorry, I forgot to mute myself.
Okay, no problem. Yeah, modern Pythonic toolkit. So yeah, this presentation is run through of the tools and practices that I use in my day-to-day work as a data scientist and software engineer and ML engineer, and all the things that I'm doing in the meantime. The idea is not that you, after this presentation, you know how to use them. The idea is that you've heard about them, and now you can Google them, and you're like, oh, I had problem with code formatting. I've heard that there is this super library called ruff, and I will check it out. Topics covered: code versioning, dependency management, code quality and standards, code organization, and validation of your applications, or quality assurance or testing. So code versioning for data science. Code versioning is crucial. What is code versioning? You should never pass around code via email or Slack. Just never. And unfortunately, even in 2024, it's still not that unused in data science teams, that they store code somewhere and it's not organized and it's not versioned. Code versioning and Git in general, because when we think about code versioning in 2024, you think almost exclusively about Git. If you don't work in like Google that has their own system for versioning things that is not like Git, it's for another discussion. So the idea is that if you code versioning is, for example, Git is a place where you, let's say, upload your code, but you don't even have to upload. You can work on your machine, and you have a snapshot of the version of your code, and we call them those snapshots. We call them commits, and then you work on this code, and you've done some changes, and you want to have another snapshot, so you're creating another commit, and another commit, and another commit, and so on. And Git offers an organized way to collaborate with other people. So how to share the code, how to work on the same code base with different people. Software engineers had this problem for decades. So they figured out what are the best practices when it comes to working on the one code base with many people. And we data science folks don't have to look blindly for solutions and come up with our own. We can just use Git from them. What I have here also, that it's for everyone. And I would say that this differentiates between professionals and the rest of Pandas users that are passing code around in some Slack messages somewhere. Git, just use Git. Now, code organization. And this is an interesting one. So it's not that much of a problem in creating PyShiny dashboards. And even though this workshop is on PyShiny dashboards, I would like to sell some tips for data science projects. Because you're working on some model, you have some filtering of data and so on. But you're also running experiments. And then it's very easy to just mix everything together and send it to someone else this way. It's nasty. So we recommend creating a package for the main code and then call it from scripts and notebooks. And we can check the example data science project as an example. So maybe let me open this. Okay. Let me stop sharing, share screen, window. Okay. Obviously, I have to zoom in. Perfect. Thanks for linking, Pavel. So, as you can see in README, I've just run Poetry new example data science project. To what is Poetry will come in a second in the dependency management section of the presentation. Then we already have this structure where we have example data science project. So this is the same name as this. So this will be the name of our package. And we define some model. For example, predict with just predict function. Something's off. Anyway, it doesn't matter for now. And you can create a function. Just in case you don't know what this means, for example, it's called type hinting in Python. And I really recommend you also to learn about type hinting if you haven't worked with Python in the last, let's say, like 4 years. It changes a lot and it's great. it's out of the scope of this part, but we have two scripts. We have model and we have serialization. That we're just mocking some serialization here. And then we also have scripts. And now let's imagine that I'm a data scientist. So I encourage you to put all your code, like logic here in model and serialization. And then in run model, we're calling those functions that we've imported. And because we're calling those functions, we can use them here, but we can also create a notebook. And this notebook, we can also use the same functions. And then we can write tests. And tests might sound scary, but in PyTest, you write tests just like that. So you have tests directory. In this directory, you have file that starts with test underscore something. And then we have function that starts with test underscore. And as you can see, it's nothing, nothing. Yeah, obviously. Let me try to debug this. Okay. Now if I run this and do I see this? Because I would like to show you all features, and for some reason, this particular environment. Okay, I will not find it right now. I can run it like this. Poetry run PyTest. So I'm running tests. As you can see, I've just run PyTest here. Don't bother with this poetry run. And we have this test run. Very simple, very easy. You don't have to write any boilerplate for testing, and you can just test it. And you can use the same predict function in your tests, in your scripts, in your notebooks, and you have it in your in the package. And you have data in some other place. It might feel not like a lot, but very very important concepts here, like separating those parts. And also, I really encourage you to order your scripts that you're using just with to prefix them with numbers. Very often you create notebooks in some sequence, and if they have prefix with the number in the sequence, it's much easier to find what you were working on. Yeah, but maybe let's come back from this detour and let's come back to the presentation. And yeah, this is the folder for the data, main logic, Jupyter notebooks, project configuration, scripts, tests. Cool. Do you have any questions here? Please write them down. I don't see any, but really feel free to ask them. We are here to answer your questions. I hope that you already got this, that we are here much more to answer your questions than to give this presentation. We cannot give presentation and go home because we're working remotely and we're already at home. Dependency management. So dependency management in Python is a mess. And every few years, someone says that, oh, we fixed the dependency management in Python. They rarely really do it. And one important thing is that you should never install packages globally on your machine. What I mean by that is you can install Python on your machine. And then you can just type, for example, pip install pandas. But the problem is that this pandas depends on different libraries. So if you install just pandas, you're probably installing many different things like NumPy and so on. And then you have another project, and this another project requires you to have a different version of everything. In R, you have, for example, rnf, and it does fairly nice work of separating different environments. And in Python, we have a few ways to get the same thing. The most basic one, included already in Python, like built-in, is virtual environment. I don't really recommend it, but if you have Python installed, you can create venv, that's called env, in this directory, and then you can activate this environment, and you can install Shiny this way. And then you can deactivate the environment. Now let's focus on two most commonly used, I would say, workflows. So one is conda plus pip. Conda is a package manager for data science in general. So it doesn't only install Python packages, but it can install basically any artifact, any package. It can install you R, it can install you Julia, and install many other things. But what's important for me as also ML engineer is that it can install, for example, CUDA drivers. And I have different versions of CUDA drivers. So CUDA drivers are drivers for GPU that we use in machine learning that requires you to use GPU, many things with neural networks. And with Conda, you can have different versions of those drivers, CUDA drivers, installed on the same machine at the same time in different environments with different Python versions. Exactly, different Python versions. While if you work with dashboards, I would say it's rare that you really that you're forced to use some kind of version of Python. But if you're a research engineer, like I was for quite a few years, I was checking up different projects, and different projects use different libraries, and those libraries were in some versions, and those versions were only compatible with Python 3.7 or 3.6 or 3.9, and it was generally a mess. And venv is a virtual environment, but for your particular version of Python. And with Conda, you can easily create different environments with different Python versions. Sometimes it's very useful. However, the dependency resolution, I think that's how it's called. So which package depends on which package is a mess in Conda. Just please be aware that Conda exists, and that if you have problems like with CUDA drivers, probably you want to manage your Python version with CUDA. But if you are just writing different small applications, Poetry seems like the best tool that we have currently. It does the best job at making environments reproducible. It encourages you to use best practices like PyProject storing code as a package. This way you interact with Poetry. You can read about it later. However, what's important, Poetry doesn't work very well with PyTorch, TensorFlow, and other things that depend on large artifacts somewhere. And for example, Torch has different version for CUDA and for CPU and for ARM MacBooks, and also have different version for NVIDIA cards. And it's generally speaking very hard to use Poetry, or even impossible to use Poetry if you work with PyTorch or TensorFlow. So if you use those, probably it also applies to JAX if you happen to work with it. you should consider using conda. And then, probably the next poetry will be uv plus fry. And this is a Yang tool from creators of Ruff. We'll go through Ruff in a second. And yeah, they promise is to build a tool like Cargo, but for Python. Cargo is a dependency and like version manager for Rust, and it's being said that it's the best thing that exists when it comes to dependency management. However, you can check it on this page. However, I don't recommend it using now because it's still in the active development. I was warned not to install multiple package managers on my... Yeah, so the question from Kai is, I was warned not to install multiple package managers on my computer, like using conda and vn for different projects. Wonder, what are your thoughts about this? My thoughts are that you should use only one at the time. So definitely, if you're creating an environment with conda, then don't use vn inside this environment because it will be a mess. I think that's the simplest answer to this question. So if you don't have like requirements that you should use this or that you have to use both at the same time, yeah, just stick to one if it's possible. Obviously, if you're experimenting with many tools, it's not possible to have installed only one tool, but maybe stick to one between different projects. Yeah. And my take is that for PyShiny things, I use poetry exclusively, basically. Code quality and standards. As we've discussed, code is much more often read than written. Consistent makes it easier to read. And high quality code ages slower. And there's this thing ruff. And it's tool both for formatting and for linting. Formatting means that the code looks nice and that it looks in one, the line is that long. If you have the function definition, then there should be a next line. Or if you have parameters, they should be surrounded by spaces or should not be surrounded by spaces, and so on. Linting means that you're checking for errors but practices that are potential errors. And we'll go through it in a second, but what's important is in linting, you don't know anything about the environment that the code is running in. So you're just looking at the code and checking whether the code looks good when it comes to what's defined after what, but it doesn't know whether you have particular package installed or not. But it can, for example, detect that, oh, you're using a variable that you haven't defined anywhere, or that you're defining a variable, but you're not using it anywhere. You'll see an examples of that. And what's cool and important is that you may have heard about Flake8 or Black or Pylint, or you may have heard about Bandit for security checks. And all of those are being basically replaced by ruff. And even Flake8 uses ruff for Flake8. Flake8 is a linting package for Python, and this package actually uses ruff because ruff is hundreds times faster than those libraries for some reasons that I don't want to go into now. But what's important is that whenever you hear formatting or linting in Python, just use ruff. Code format. those two are, valid Python code. But those are ugly. If you run ruff format, we get this. Obvious. But what's nice about ruff check is that you have this function. Okay, so I want to divide A by B. I define the value. I return it. Cool. I run the ruff check example.py, and I get this error that local variable C is assigned but never used. And now I'm like, oh, gosh, really? Because I wanted to return C, but I'm returning A. So I was able to catch an error, not at runtime, but I was able to catch the error while I was, creating the code. Really, really nice. Exactly. And now there's also type checking. So let me check what Pavel has.
Oh, please don't be distracted.
Okay. Anyway, type checking. So one, 1, 2.
I can hear you, but your video is frozen. Maybe try to turn off your video and turn it again, because I can hear you. Now I can see you clearly. I think the problem's gone. Can you hear me? We're having a technical issue for a second. Thanks, Barrett, for confirming. Oops. Okay, let's give Pasha a minute or two to rejoin. If he does not, I will pick up the presentation. Yeah, right. That's true. That's so true. I can relate, especially every time when you have some developer tools that run so fast, you don't believe it. Like you're not sure if you run it or not. Absolutely can relate 100%. Hi, Pasha, I can see you. I cannot hear you.
I think I've lost the internet connection or something. But I'm back. Can you hear me?
I can hear you now, and I can see you. Yep.
Perfect. Okay, that was kind of unexpected. So, where have I been? Just as Brett said, yeah, ruff is so fast, you don't even feel that it's working. Usually it's being run in the VS Code in the background all the time. Back to the topic. So ruff analyzes our code without knowledge of the environment that it's running. And then you can also have type checking with MyPy or pyright that knows about the environment that you're running your code in. So for example, it can check whether the package that you imported has function that you want to call. For example, if you run this code, ruff check doesn't catch any error here, because from the ruff perspective, everything is correct. You've imported something as NP, and then you're calling some function or some on this NP thing, and you're passing a list here. So it looks okay. But from MyPy perspective, we get module has no attribute existing function. And that I it's not some error.
Wait a second.
Function. Yeah.
You are experiencing severe levels of robotic voice right now.
How about now?
It was good. Try again.
That's very unfortunate, but how about now?
I think your connection is not very stable.
And how about now? Is it more stable or not?
Sounds good. Try again.
Okay. And do you see my screen?
I see your screen, yeah.
Okay.
I think it's stabilized.
So, okay. The point is that there is this MyPy that catches this kind of error, and it's also static type checker. So if you add type hints to your code, MyPy check if you follow them. So for example, if you create this function, you'll get error incompatible return type, got float expected int, because this division returns float always. And we say that we will return int. And I cannot stress enough how big of how big of an advantage it is, and how it completely changed how you work with Python code. It's very, very useful. You have to remember that if I write the function like this in Python, I don't enforce those types. Those are just suggestions. And I can write type just for one of those parameters. And all this type checking stuff happens on the like before we even run the code. When we're running the code, we don't have anything about types being inferred. So MyPy helps. And let's consider a more advanced example. We have some data class. If you don't know what is data class, it allows us to not define the constructor for this person, and we can just create person like name, age, and we'll create a class with name and age. Great. And now let's say that we're getting some results from database. We have function get database records, and we know that it should return list of tuple, string, and string. So we have list, and has and each element of this list is of type tuple that consists of 2 strings. And MyPy catches 2 potential errors. Let's have like a shorter version of this. So here it says that tuple str none is not compatible with str because here we have none. So we are able to catch this error. And then we also catch that person is incompatible with string parameter like argument 2. So this argument is string, and it's expected to be an int. I guess it's self-explainable, but it's nice that MyPy can catch those errors. Once again, before we even run this example, yes, so we don't have to run this example and then discover, oh, we messed up, but we are writing code and we see, oh, we messed up. And pyright is static code checker, static type code checker by Microsoft, MyPy is by some other organization, and so on. The point is that probably you will be using pyright in VS Code while you're coding. This is the default thing that tells you what types are things in VS Code. And MyPy is a thing that you will be using in your CI/CD. So in your pipeline, because pyright depends on Node.js and like on some JavaScript environment and so on, and MyPy is a purely Python package. But in reality, you usually don't have functions like this. You usually get some data from API or database. And then if you parse an external JSON that can simulate the returned thing from the API, type hints won't help you. However, Pydantic will. And if we consider this example, let's say that this is a JSON that we have, and we are loading this JSON, and then we are creating person from each record of this JSON. And now it doesn't happen on the, like when you're writing the code, because you're not reading this file, in VS Code. But when you're running this code, you get the error, that validation error for person age input should be a valid integer, and type input value was none, and it should be in, and so on. You may not think that it's that cool when you see this example, but please consider this, that we have something like data class, but in data class, no one actually checks what types are things. Only the static type checker, yes, but not during runtime. During runtime, we can easily pass, for example, this none into age here, and this string into name, no problem. While Pydantic will just, cry that it's that the thing is of the wrong type, and you will be able to catch errors much more easily. And just remember the phrase Pydantic. Yeah. Data class will be silent about it, and remember that hints are just hints, and they are not enforced by Python interpreter. Is MyPy pyright a part of IDE like VS Code or RStudio? I don't know how it works in RStudio, but in VS Code, there is an extension for Python by Microsoft. I think it's called Pylance, and it runs pyright in the background. So in some sense, yes, it's part of IDE. And I can actually do something like that. So let me share screen. Hop. Okay, so if I create a function, let's say divide a int b int b, because I have, when I click here, I have auto type checking basic. When I switched it to off, I don't get any errors here or information or whatever. But if I switch it to on, I get this. Expression of type float can be assigned to return type int from Pylance. That's from pyright. I hope it answers your question. I really encourage you to turn on the type checking when you're working with your Python code. I think that was an important thing. Hop. More on validation quality assurance testing. So business needs to have dashboards validated. Companies have dedicated quality assurance teams. And we software engineers called process of application validation of at least part of this process testing. So we really encourage all our clients as Epsilon to invest in testing. And we know that if the app is tested, it's much easier to work with this app. You can change this app. And if you change something, you know whether it still works or it stopped working. And you know where to look for errors. And I cannot stress this enough. Yeah. If you validate, if you want to mimic the real user behavior, we call this kind of testing end-to-end testing. And it's not that some function runs with some parameters and we're happy. We're actually really simulating clicks and typing in inputs, but in a programmatic way. So for example, when I develop the application, I don't have to manually always check, and put those inputs and remember what to click there. And I have to remember that, oh, there was this use case, this test case, and this test case, and I have to check all of them. I can just run PyTest. So for testing, we recommend using PyTest. As you already have seen, you don't need to write any boilerplate. So we've already seen this example. What's cool and what's actually important is, in Rhino, so in our framework for building apps in R, we have Cypress for end-to-end testing. And this library requires you to write tests in JavaScript. Fortunately, in Python, there is a library called pyright, and this library allows you to write end-to-end tests in Python. And they look, for example, like that. So if you want to test footer, we go to page where our app is already launched, and we say that, okay, page get by test ID. So we have some test ID for the footer, and we expect this this part of the page to contain, for example, by Epsilon with love. And Pavel, if you could if you could find the PyShiny testing blog post on our blog that has been released like a week or two ago, and please paste it into chat. You will see how to write tests in different ways, and I really encourage you to just read this blog post. And that's almost all that I have for those slides. The post has been shared. There's some hacks, some new hacks is joining soon the Epsilon hacks family, and yeah, stay tuned for that. So I will not say more here. Just stay tuned. Now we have 7 minutes left, so I will go quickly through the comparison between different frameworks. And this is the last opportunity to ask questions on the chat, and I really encourage you to do this. Someone asked about the available session chat available with recording after the fact. I'm not sure. You can definitely copy it for yourself. That will be a future-proof solution. Someone asked whether you can use Golem on Rhino or Rhino together with PyShiny. And the answer is no, because they are for R, and for Python you need something else, and I will not say anything here more. Do you have any previous workshop presentation on RShiny that we can see? Yeah, I guess Pavel, please handle this question, and that's it. So I think that the most interesting part is to see the Streamlit versus Shiny comparison. At least, yeah. Why? Because at first I was not convinced that Shiny is something cool in some sense. I felt like, why should I even write in PyShiny? I have Streamlit and I'm happy with Streamlit. And this example convinced me that, oh boy, I was wrong. So we have two applications, and as you can see, they are very similar in the layout. So we have Panda, we have Shiny Express, and we have Streamlit. And okay, in both of them, we are defining some title. Then we have some slider, and then we are loading the data, right? And yeah, here I would argue, oh, that's much nicer because I take this slider and I use this slider, this variable already here to get head of this data frame, and I display this data frame. Let me maybe show this example. So Command Shift P and Shiny run Shiny app. Okay. Huh. Why is it working? Okay. I guess I have to do it manually. Kill me, it always happens. It always happens at the wrong moment, isn't it? Let me just do this and
Don't worry. Breathe in, breathe out. We don't have much time left. Maybe we can go over differences.
Yeah, I just want to show you the application. So that's a simple application. The same is in Streamlit. And let me just share the example of second application. Hop, 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 hop. And in this application, you sample some rows, and then you can drop some species. And it works just as you would expect it to work. So if we sample some rows and I drop some species, and I undrop those species, we have the same sample drawn here, because that's the way you would expect it to behave. And in Streamlit, in this application, hop, Streamlit run up to Streamlit. If I, for example, drop this and then drop Gen2 and undrop and now drop Gen2, a different sample is being drawn every time. And that's because in Streamlit, the whole script is being rendered every time we change any interactive input. And this is something that I would like to leave you with, and I encourage you to go through the rest of examples and comparisons if you find them interesting. Stay tuned for the upcoming release of the hacks that I've shared with you already. I hope that you've learned something, no matter whether you're very on the intro level to PyShiny or Python in general, or you're advanced RShiny user. And well, thank you for having us. And feel free to stay tuned to our blog posts and more.
Thank you, Pasha. You did a great job.
Thanks.
4-hour marathon. That's a lot.
Yes. I'm. I think I can say that I'm very tired. Yeah. I don't know if this Discord channel will be working nicely for you, but this is the Discord for PyShiny, and I see that some of you haven't left yet, and check out new things from PyShiny there.